Welcome to my channel Talking Physics with P.R. Sarkar. In the previous day, we shall learn about the application of Gauss's theorem in case of infinitely charged wire or infinite sheet. But today, we shall know the application of Gauss law in case of thin spherical shell which is uniformly charged and for sphere, and do numericals related to it. So, keep watching, don't skip for better learning. So, today we shall deal with the application of Gauss law for thin spherical shell. Thin spherical shell. Now, what is thin spherical shell? Now, we know that shell looks like something this type. Two concentric spheres in which this portion is solid and this portion is solid and this portion is hollow, is form a spherical shell. Now we have to find out the electric field due to this uniformly charged spherical shell. Suppose this is a spherical shell of radius r which is given charge q. We have to find out the electric field, and we have to find out the electric field at an internal point P1 and an outside point P2. How we can find out the electric field at P1 and P2? So, at first we have to draw two Gaussian surfaces. It is said that the radius of the spherical shell is r. Now we have to determine the electric field at point P1 which is at a perpendicular distance x. So P2 is also perpendicular distance x, where in the first case x is less than r, that is x is inside the spherical shell. That is the point P1 is inside the spherical shell. So we must have draw a Gaussian surface, that is a spherical sphere, a spherical surface which is treated as Gaussian surface within the spherical shell. We know that the charge inside any shell, any conductor is 0. So when x is less than r, the charge q equal to 0. Therefore, E dot ds as per Gauss law equal to q divided by epsilon naught. As q is 0, therefore E must be 0. So at any inside point the E is 0 when x is less than r. Okay. An electric field is always directed radially outward. For point P2 also, if we consider a surface area here, so the direction of electric field is along radially outward. E is along radially outward. So when x less than r, the electric field is 0. Okay. Now we can go with case 2. When x is greater than r. From the figure we know that x is outside the spherical shell, as the radius of spherical shell is r, so x must be greater than r. So for this case we have to find out the electric field. Again we can draw a Gaussian surface which is pass through the point P. Here by symmetry it is sphere or spherical Gaussian surface. Now the electric field is always radially outward if the charge is positive. Here we can say that the plus q charge is induced. If it is negative, then the direction of electric field is towards the charge. We know it from the previous discussion. So for here, when x is greater than r, as the ds vector and E vector are parallel to each other, so we can say that E ds cos 0 must be equal to total charge. What is the value of total charge? Q by epsilon naught. So E is, by symmetry, E is directed radially outwards perpendicular to the surface, and the value of E is all same at every point on this spherical surface. The value of E is same at every point in this spherical surface. So E ds cos G is taken outside the integral, ds equal to Q by epsilon naught. So E multiplied by 4 pi x square equal to Q by epsilon square, E equal to 1 by 4 pi epsilon naught Q by x square, or Q by 4 pi epsilon naught x square. Okay, this is the same as if the charge Q is located at center Q O, the charge Q is located at center O, and at a distance x, the electric field is given by 1 by 4 pi epsilon 0 x square. We know that from the previous discussion that if a point charge Q is located at a distance x from a test charge Q0, then the electric field is given by this formula. Okay. Now we know that from 0 to R distance the electric field is 0, and outside R the electric field is varies with inversely to x square. So if we draw E versus x curve, this is the distance x and the variation of E is taken along y axis. So at 0 to R distance the electric field is 0, and at x equal to R means E equal to 4 pi epsilon naught R square. X equal to R distance the electric field is maximum, and then it decreases with x square. So the graph will be taken as G, this type. This is the maximum electric field, then it is decreased as inversely to 1 by x square. So we can find out the electric field of Gaussian surface for a thin spherical cell. It is easy. Next we go with the same treatment for a solid sphere. What is difference between spherical cell and sphere? Spherical cell is the center is hollow and the outer surface is solid, but a solid sphere is everywhere solid. Okay. So now we go to calculate the electric field for sphere or solid sphere. So write down the electric field is for solid sphere. If for solid sphere, if you have to problem with understanding, please write in my comment box that how my teaching was reaches to you, is it is good or bad, or I will try to my level best. Okay. So if this is a sphere of radius r, then again we have to calculate 2 at 2 point P1 and P2, which is at a distance less than r and at a distance, suppose P2 is this point, at a distance greater than r. So for first case, when number 1, when x is less than r, suppose Q is the total charge is Q, and rho be the volume charge density, that is rho is total charge divided by volume 4 pi r cube. Now what is, if we take P1 point and if we draw a Gaussian surface, that is again sphere concentric with the solid sphere, then of radius x, then this is treated as Gaussian surface. Then what will be the charge inside this sphere? Look very closely. Q is the total charge, then charge per unit volume, charge per unit volume equal to total charge by volume. Again, what is the volume of the Gaussian surface? 4/3 pi x cube. Therefore, the charge within Gaussian surface if say Q1 given by Q by 4 pi r cube multiplied by 4 pi x cube, total volume. 4 pi cancel out, we can get q x cube divided by r cube. This is the total charge within the Gaussian surface. Okay. Now again, the direction of E is radially outward and parallel to ds. Same formula, E dot ds must be equal to which charge? Q x cube. If this is small q, then it is small q, or say it plus q, q x cube by epsilon naught r cube. Okay. So E again is constant, E integration ds equal to q by epsilon naught x cube by r cube, or E multiplied by 4 pi x square. Look here, 4 pi r square noy, not 4 pi r square, as the Gaussian surface has radius x, so it is written as 4 pi x square equal to q by epsilon naught multiplied by x cube by r cube. So E equal to q by 4 pi epsilon naught into x cube divided by r cube x square. X is above, so we can get qx by 4 pi epsilon naught r cube. Now rho equal to q by 4/3 pi r cube. So from here we can say that q by 4 pi r cube equal to rho by 3. So we can say that E equal to q by 4 pi r cube equal to rho by 3. So rho x by 3 epsilon naught. This is the electric field inside the solid sphere, rho x by 3 epsilon 0. That is E, electric field is proportional to x. We draw the diagram later. Okay, please write down it. Okay, I hope you consider it. If any problem arises due to understand, please write. I will write in your I will definitely reply your question. Okay. Next we shall go with the next problem, that is outside the sphere. Outside the sphere. So outside the sphere, mistakenly I have deleted the picture. So you can draw only the outside picture P2, which is at a perpendicular distance x. We take again a Gaussian surface x. Okay. So now we can deduce it for x greater than r. X greater than r. So for x greater than r, that is outside point. So again, if we take ds vector, then again E is point out radially outward and ds is parallel to s. So integration E dot ds equal to, here one thing consider that the charge is the charge of the solid sphere, that is q, because the sphere is inside the Gaussian surface. Okay. So it is written as q by epsilon naught. So E multiplied by 4 pi x square equal to q by epsilon naught, or E must be equal to q by 4 pi epsilon naught x square. Okay. Now, at x equal to 0, what occurs? In the previous case, we can get E equal to rho x by 3 epsilon naught. At x equal to 0, E equal to 0. And at x equal to r, if we put r, then E equal to 1 by 4 pi epsilon naught q by r square, which is the maximum value of electric field. So if we draw for thin solid sphere, E is along y-axis and x is along x-axis. For here, x equal to r. So in the first case, we can that E is proportional to x, that is this type. Here is E is proportional to x. At x equal to r, it becomes maximum. Which value? This value. 4 pi epsilon 0 r square, 1 by 4 pi epsilon naught q by r square. Okay. Now, okay, in the previous case, you can consider it 3 epsilon, because if it is made of, epsilon is the material permittivity of the sphere. You can write it epsilon in case of epsilon naught. And then it is inversely proportional to r square. So the graph will be hyperbola, rectangular hyperbola. It is inversely proportional to 1 by x square. Proportional to x, 1 by x square, x equal to r. Here, for here, x is less than r. For here, x is greater than r. So in this way, we can find out the electric field due to Gauss law for any spherical surface. Let us do with a numerical for understanding. Okay. I hope you are learning very well. Now we go for a numerical. So, suppose a thin spherical shell is induced by charge q. Another charge q by 2 plus q by 2 is located at center O, and again another charge plus 2q is situated at a distance x from the center. Find out total flux phi and force at O, and suppose this point is A. Okay. This is a thin spherical shell, not solid sphere. This is spherical shell. Remember, the formula will be different. Okay. What is the phi? Now, number one, what is charge inside this q by 2? Because q and 2q are outside the integral. So Gauss law always state that total flux must be equal to the total charge inside the sphere, total charge enclosed by the surface divided by epsilon 0. So here q and 2q are not enclosed, but q by 2 is enclosed. So total flux phi must be equal to q by 2 total charge divided by epsilon 0, or epsilon naught q by twice epsilon naught. This is the number one answer. Number two, force at O. Force at O, F becomes QE. But inside the sphere, E is 0. We know that inside every conductor, the total electric field is 0. So for here, FA, or if you write FO, that is the force at point O, equal to Q into 0 equal to 0. Okay. You can say that Q by 2 charge is located here, but this charge will be distributed in the outer surface. The net electric field inside the sphere is 0. Number 3, force at A. Again F equal to QE. F A equal to Q into E. What is this Q? 2Q plus 2Q into E. What is the value of E? Q dash by 4 pi epsilon naught x square. What is this q dash? Q dash is the sum of q by 2 and q. So we can write it as 2q into q plus q by 2 divided by 4 pi epsilon naught x square. So 2q into 2q plus q, that is 3q by 2 by 4 pi epsilon naught, 2 to cancel out. We can find that force F equal to 3q square divided by 4 pi epsilon naught x square. Okay. So the force at O is 0 and force at 2q is 3q square by 4 pi epsilon naught x square. So this type of problem will be given in your in your upcoming exam. If you like my video, please subscribe my channel. I will thoroughly do the whole 11-12 syllabus with NEET and JEE question practice. Okay. So for today, thank you very much.